Ever wondered how our body communicates with itself? It's not magic, but a complex and fascinating process known as nerve impulse transmission. This process is the cornerstone of our body's internal communication system, allowing us to think, feel, and interact with the world around us. From the tips of our toes to the neurons in our brain, nerve impulse transmission is the silent language our body uses to function. So, buckle up, because we're about to unravel the mystery of nerve impulse transmission. The story begins with a neuron, the basic unit of our nervous system. Picture a tree in your mind and you'll have a rough idea of what a neuron looks like. This tree-like structure has several key components. There's the cell body, the trunk of our tree, which houses all the neuron's vital machinery. Branching off this trunk are the dendrites. These act like roots, soaking up information from neighboring neurons. Then there's the axon, a long, cable-like structure that functions as the neuron's highway, sending electrical signals down its length. And finally, we have the axon terminals, the leaves of our tree, which pass on these signals to the next neuron in line. Each of these parts plays a crucial role in the neuron's function of receiving, processing, and transmitting information. A neuron is, in essence, a tiny information highway. A nerve impulse or action potential is born when a stimulus exceeds a certain threshold. But what exactly happens during this fascinating event? Well, let's dive into the details. When a stimulus is strong enough, it changes the neuron's membrane permeability to sodium ions. This change allows a rush of sodium ions into the neuron, inverting the electrical balance and causing a rapid depolarization. This depolarization is the key to the birth of a nerve impulse. It's like a spark that sets off a chain reaction, turning the once quiet neuron into a bustling hub of electrical activity. Sodium ions are the heroes of this story. Their movement into the neuron creating the crucial change in charge that sets everything in motion. And just like that, the nerve impulse is sparked into life, ready to race down the neuron's axon. This rapid change in electrical charge sparks the nerve impulse into life. Once born, the nerve impulse embarks on a journey along the axon. This isn't a leisurely stroll, it's quite the opposite. Imagine a sprinter racing along a track. That's the nerve impulse. But instead of a smooth, linear track, our sprinter is leaping from node to node of Ranvier. These nodes you see are tiny gaps in the myelin sheath, a protective layer that coats the axon. It's like a game of leapfrog, but at a microscopic level and at an incredibly high speed. This process, known as saltatory conduction, accelerates the transmission of the nerve impulse, ensuring it reaches its destination in no time. The destination? The axon terminal, the finish line of our sprinter. Here, the nerve impulse triggers the release of neurotransmitters, chemical messengers that will carry on the message to the next neuron. The nerve impulse has now reached the end of its journey, but its mission is far from over. The arrival of the nerve impulse triggers the opening of calcium channels at the axon terminal. This event is like a grand entrance at the end of a red carpet, signaling the spotlight moment for calcium ions. As these ions flood in, they act as the key player in the next step of this intricate process. They provoke the vesicles, tiny storage units within the neuron, to release neurotransmitters into the synaptic cleft. Imagine these neurotransmitters as little messengers carrying the impulse's information. These messengers don't wander aimlessly, they have a specific destination: the receptors on the postsynaptic neuron. Each neurotransmitter fits its receptor like a key in a lock, ensuring the correct message is delivered. This binding can result in either an excitatory or inhibitory response, depending on the type of neurotransmitter and receptor involved. And just like that, the nerve impulse has successfully delivered its message. Let's take a moment to appreciate the complexity of this process. We've seen how a nerve impulse is generated, sparked by a stimulus, and leading to a rapid change in membrane permeability. We've followed its journey along the axon, hopping from node to node until it reaches the axon terminal. And finally, we've witnessed the release and effects of neurotransmitters, enabling communication across synapses. This intricate dance of ions and neurotransmitters is happening right now inside your body, allowing you to watch this video. Isn't that amazing?